When you see a mix of square roots with fractions, the big things to keep in mind is that you can't leave the square root in the denominator of a fraction, and we're going to use a property where if you take something that's underneath the square root symbol and multiply it by itself, the square root symbol is just going to cancel out, and whatever was underneath there is going to be left alone. The reason why this is happening is because when you multiply something by itself, you're essentially squaring it. So this is the same thing as saying root a squared. And of course, squaring and square roots are opposite of each other, so these end up canceling each other out. Let's see that in action. Over here, I see I've got a 3 over square root of 5. I don't want to leave square root of 5 in the denominator. So to get rid of it, what I'm going to do is multiply both top and bottom of this fraction by the square root of 5. When we're doing the top, one number is under square root and one is not. So when we multiply these things together, we can't really do much other than say it's going to be 3 times the square root of 5. On the bottom, I'll have root 5 times root 5, which is essentially root 5 squared. Squaring and square roots are opposites, so basically these both cancel, and we get a 5 on the bottom by itself. It doesn't look prettier, but the square root's not in the denominator, and that is our goal. On the very next problem, we see this time the square root's over the entire fraction. That's where we can use this fun property. We are totally allowed to break a radical up over the numerator and the denominator. Then I take a quick pause. I'm not allowed to have a square root in the denominator. However, in this case, I know the square root of 9 is 3. Just plain old 3. The square root goes away. So, while I don't know what the square root of 7 is, I don't really care. This becomes 3. There's no square root in the denominator. I'm done with this problem. The next problem kind of takes a mix of both of these problems over here. First thing I'm going to do is take that fraction and break it up, make it root 2 over root 13. Now I've got a square root in the denominator. I can't have that. So what I'm going to do is essentially square this, but not quite square it. I'm going to multiply it by root 13 and do the top with the same exact number. So this bottom is root 13 squared. The square and the square root cancel, so this just becomes a 13. And the top, I'm going to multiply these two things together. Now, unlike the first example where one was underneath the radical and one was not, these are both underneath the radical. So I'm going to use this property again and say this is the same thing as square root of 2 times 13, or my final answer will be square root of 26 all over 13. When I look at all three of these answers, I notice that in all cases, there's no square root in the denominator. Sometimes I can get there easily because the denominator square root's no problem. Other times I have to take whatever that square root was and multiply it by itself so that the square root cancels. So when it was root 5, I did root 5 times root 5. That became just a plain old 5. When I had a root 13, I did root 13 times root 13. That made the bottom just 13. So as you move forward, think about and pay attention to if your number's underneath the square root or not, if it's a perfect square or not, and at the end of it all, just make sure that you don't have any square roots in your denominator, and it's going to be okay. Good luck.